Section 7.6, finding the equation of a polynomial when they give you the roots of the function. So we're going to take a look at the notes handout that I gave you after the quiz today. The first note here, a third-degree polynomial function is called a cubic function. C-U-B-I-C, that's a cubic function. And what we have here in example 1 and example 2 are two cubic functions. And the one thing that I want you to notice about these is that they have the same x-intercepts. They have the same x-intercepts, negative 2.5, 3.2, and 7.5. However, example 1 goes uphill, downhill, uphill, while example 2 goes down, up, down. If we consider that parabolas could do that too, let's do a quick drawing here. I hope you understand that two parabolas could have the same x-intercepts. It's just one would be up and one would be down. So it's possible with quadratics, it's possible with cubics, that they could have the same x-intercept, but different functions would produce them. What I want you to notice is their y-intercepts. This one is 0, 240, and the other one is 0, negative 90. Those two y-intercepts will come into play as we go to find their equations. So what we're going to do is start with factored form. And for a parabola, factored form was x minus r1 times x minus r2. That was for a parabola with maximum 2 roots. Well, now we have cubic functions that may or may not have 3 roots to them. So we're just going to tack on a third parenthesis with x minus r3. Root 1, root 2, root 3. So these two cubics will actually look very similar. One's going to be x plus 2.5 to represent the first root, negative 2.5. The second parenthesis is going to be x minus 3.2 to coincide with 3.2, as you see there and there. And the third one's going to be x minus 7.5, and that will go with the third root that they gave us, 7.5. Where they're going to differ is the value that we end up with for a, the dilation / reflection coefficient out in front. So how do we find a? This goes down to the second point here. How do we find that a? Well, we're going to use the coordinates at the y-intercept. The first one had a y-intercept of 0, 240, while the second one had a y-intercept of 0, negative 90. So we're going to go ahead and take the equation that they gave us, or that we just compiled right here. I'm going to circle it in green. And what we're going to do is we're going to replace, for example, 1, we're going to take 0 and plug it in for x, while we put 240 in for y. So it would say 240 equals a times 0 plus 2.5 is 2.5. 0 minus 3.2 is negative 3.2. 0 minus 7.5 is negative 7.5. So here's one equation that we'll use to find a. In the second example, we're going to do the same thing, but we're going to change the 240 to negative 90. So I'm going to go ahead and leave this equation in place, and let's go ahead and solve for a. So we need to multiply 2.5, negative 3.2, and negative 7.5. So here we go. When you take 2.5 times negative 3.2 times negative 7.5, you get 60. So all this ends up equaling 60. A equals 240. We're going to solve for a by dividing both sides by 60. So a must be 4. So the equation that we have for example 1 is going to be y equals 4 times x plus 2.5 times x minus 3.2 times x minus 7.5. So what I'd like you to do is try doing example 2, and instead of starting off with a value of 240 over there in green, I'd like you to change that to negative 90 and see what your new value for a is. Okay? See what your new value for a is. when you put negative 90 here, everything else will be the same. 0 went in for x. You're going to divide both sides by 60. You're going to get a new value for a. So example 2 will be y equals some number times x plus 2.5 times x minus 3.2 times x minus 7.5. So what I'd like you to do is graph this in y1, the red one in y1, and just make sure that you get the graph that you started with in example 1. And then go ahead and graph the other one. You can put it in y2 and check to see if you get the graph that we saw in example 2. Finally, example 3, this will be for you to do on your own from scratch. Find a polynomial whose graph has those x-intercepts and that y-intercept of 180. And I want you to describe the features of the graph. What I mean by that is I want you to talk about a concept called end behavior. If we look at the first graph, notice how it goes uphill, downhill, uphill. It starts uphill and ends uphill. Think about what A was for example 1, and think about if that has anything to do with the shape of the graph. In example 2, it goes downhill, uphill, downhill. Its end behavior is in downward fashion, and a downward fashion at the beginning and at the end. Think about what A was for that problem, and think about if it has any significance to it, okay? And then go ahead and do that for example 3 as well, where you're going to graph, think about its end behavior, and find the A, put all the pieces of the puzzle together, come to class ready tomorrow to ask questions and do some problems. Have a good night. Have a good